Yes, good evening, everyone. What you're seeing is a temperature controller for a freezer. It has a display, it has buttons. These are buttons for adjustments, for powering on. This is a display, it is made of LEDs. You can see there are 7 segment LEDs, and you can also see some of its parts. Let's also talk about some of its parts. One of them is this relay here. This relay is the one which switches on the compressor, and this other relay is for the fan, the evaporator fan. Then this black item here, or black thing here, is a step down transformer. It receives 240, the standard of Uganda, and steps it down to 12 volts. It is a 1.5 volt ampere transformer, and it has these terminals. Has 4 terminals. There is one here. There is another one here. Then the two are here, and this and this. So these are the outputs, and these are the inputs. Then furthermore, we have an IC, or we can also call it an integrated circuit. This IC is a ULN 204. It is responsible for switching on these relays. So these relays here are switched on by this IC here. This small IC, it has 16 pins, 16 inputs. Among the 16 pins, there are outputs. There is power supply for it to function, and outputs. It can supply up to 50 volts and 500 milliamp hours. And it has inputs which are compatible according to its manual. By the maker is ST, and it is also called a seven Darlington arrays, over seven Darlington IC. It has inputs that are compatible with DTL, TTL, PMOS, CMOS. All these are they are input signals, and it can also be applied in driving a wide range of loads like solenoids, relay DC motors, LED display filament lamps, thermal printheads, and high power buffers. And another item that we can talk about is this small item here. If you can see it, that Kawan DF06. This is a bridge rectifier. This bridge rectifier here receives the AC that we've supplied and converts it to DC. This DC here is used to power on this relay and this relay. Then the same DC is also responsible for powering this LED, powering this IC, and what else? It is also used to supply these buttons here. Yes. Then which other item have we not talked about? Under here, under this LED and under this display, we have a microcontroller inside there. Then we also have some transistors here. 1, 2, 3. These are SMD transistors. SMD. SMD stands for surface mounted devices. So we also have SMD resistors. We have an SMD capacitor here. We have another. What is this? This is a resistor. Could this be a resistor?
I'm not sure of this. Well, we've not talked about this. This is a capacitor. So this capacitor here, maybe let's talk about how power comes. Now our power comes uh, like this, follows as it moves as follows. So it is fed through 5 and 6, then through 5 and 6, this 5 and 6 supplies the transformer here for the board to operate, and it is also the same point 6 is where this relay here picks its power, the power, the power that is going to feed the compressor. So it picks it here. Then the same relay here, this one here, also picks power from here. Then after picking power from here, the output to the fan comes here, and output from this relay is here. So this output from here goes to the compressor, and output from here goes to the fan through from here. Then what else? When power comes here, this C bridge rectifier step C converts it to DC. This DC here is stored on this capacitor. It is a 1000 microfarad capacitor, and it can hold up to 35 volts. Then after here, these other items or devices or components pick the DC from this capacitor here. So this is where this SIC picks power. Then the regulator for this microcontroller also, because this microcontroller does not operate at the 12 volts, so it has to be lowered down by the regulator up to around 5 or 3.3.